All right, let me get a sound check. Looks like you guys can hear. That's good. Let me pull up my environments here. Probably put this in some dark mode. There we go. Get my notepad up. All right, let's see what's going on. Go pop it on our little cozy scene here while we're waiting for people to show up. Looks like it's pretty cold in most of the country. It's only about 60. Let's see what it is here in Phoenix. It is 66 right now, so we're relatively. I can be outside like I am in my little screen there. So what are we doing today, right? People, how's it going, Zorgal? What are we doing today? You guys wanted to hang out and talk shop a little bit. I haven't been on in man a while. But what I wanted to do was kind of continue on this little talk that we had been doing, which was like getting into Linux administration and Linux security. And I kind of have a focus here on getting us into, doing these jobs, doing this type of work, but doing it from a, like, this will be the Linux administration, but like, what do we need to know about security? Man, we need to know so many things as an administrator, but obviously we just can't, shotgun them all into your brain. We have to spend time working on them. So this is going to be a set of labs that I put together a while ago. If anybody wants to do the labs with me, you can. I will link them on the Twitch and the YouTube side there. Also on the YouTube side, I chose to jump over to a different, normally I'm in like science and tech over there or something, and I jumped over into, what did I go to today? I'm in like education, so we'll see what that looks like. So this is the lab, and let's make sure I'm in my other system here. Let's go jump over here. Yeah. So we got some stuff we can look at. If you've got your own home box that you want to jump into and do some of this stuff with us, you can. The lab is a little more directed and kind of makes it easy for us to be in the same environment in case anybody has questions or that kind of stuff. Okay? So that's something to think about as we're kind of going through this. So the way the labs work, Killer Code is free. All you gotta do is hop in there, give them an email. I don't even think I've ever seen anything from them. Like they don't even send you emails, so they're a pretty good little site. You can pay them if you want, but I've been using them for almost 3 years, I think, and I've never been charged anything from them. So they're a pretty good little site. They give you a terminal. You can just drop in the terminal, and if nothing else, you could just do the commands and see how the commands interact with you at a terminal. I think there's some value in that. That's maybe like the lowest level of value, just watching what happens. Then we're also going to talk about it a little bit. I've got my notes over here on the left and questions. Whenever we ask ourselves questions about things as we work through and we're trying to learn something, an effective method for, again, stuffing it into your brain is asking yourselves questions, right? Like, so you do a task, right? And then when you're done, you look at that and you say, okay, do I know where to go check the alerts for logins? Like if a user was really logging in here and I had to prove that or document that or show that in some way, could I do that? Right? And so we're just like kind of checking off down the list. Some of us do it mentally. It's useful to maybe write it out the first time. Also, if anybody needs these notes, these are up in the notes channel of our Discord. It's called Meeting Notes. They're from a few months ago. I think maybe even a year ago now. I wrote these a long time ago. But we're going to go through it, and if anybody wants to go through it with me or just hang out, you guys can ask me questions. You can backseat, as they like to call it. You do pretty much whatever you want. So here's our scenario. Your security operations team has informed you that an alert for unknown users has gone off on your Node 01 instance. Okay, so what does that mean? That could mean that you guys have security logs going to some logging type device and it's looking for certain things. Splunk does this. I've seen some pretty cool rsyslog filters that'll do this. There's tools like what's that tool that we have in the environment, but we don't really use much? I know I set up a lab. I set up a box for it a while back. It's in our environment, but we don't really use it much. Wazoo. Wazoo, you guys heard of this one? This is one that I set up a box. We don't really do anything with it. He's off right now anyways. But my point is, your logs are going somewhere. We tend to call that place that those logs are going a SIEM solution, right? Security, information, and event monitoring. Some people call it security, incident, and event monitoring. That's what I had originally heard it as, but the technical term is security, information, and event monitoring. So logs are coming out of your servers and going somewhere, and your security team has gotten on your case about it, or they've put in a trouble ticket, or there's an automated alert that's gone off somewhere, right? My point is, your team has informed you that something's happening. So now we need to go figure out what's going on. So we're going to connect to the other server, which is node 01. We see how to get over there, right? Normal SSH. And we're going to look at an attempt to log in and determine what happened, right? Add the usernames that are found into the root users file, okay? And then add the number of attempted logins into a file called root attempts. Now, that's just so my lab can grade you and allow you to move forward. If you want to hit, I think if you hit check twice and it fails, then you can just hit skip. So the lab will move you forward either way. But I SSH'd over to node 01. That was the first activity, the first little thing we needed to do, connect over there. And now we're going to go look at the var log auth log, and we're going to see that there were some login attempts. There were failed password and failed logins for a suspect 1, a suspect 2, suspect 3, and a real user account. So there were 4 accounts that tried to log in that we can see right here. Now that's a lot of information, right? So we might parse that down by looking for just the word invalid, and we can use the grep invalid like that, or we can use a lowercase I, -i, and then just say ignore the case, and if it's upper or lower, give it to me. Now in this case, it's probably going to be actually that does give us a little more information, so that's something to think about, how you want to parse out your information, right? So grep-i will show you more, and it looks like this invalid account has tried to get in. You know, we see all the different times that it was called invalid, but there were only 4 actual login attempts, right? One for each, right? We're seeing all the other information there too. All right, so anyway, so we can see that, and then the question is, so send the usernames into a file called root users on control plane. So we're going to exit back to control plane, and we're going to SSH over there and just grep invalid, and then throw that to our our root users. So if I more root users, I should have the output from that file on that remote machine over there. It captured it coming back to standard output, and it threw it down into the file for us. So we see all that. Also, every time I look up, I notice I'm wearing slightly green. I don't know if this is dark blue or something, but it looks like my little thing's passing through me, so that's kind of funny. It amuses me anyways. All right, so then we echo the number 4 into root attempts, and that would allow us to move forward. Okay, so validation was successful. We did that first part of the lab. Now we might back up for a second and say, where do we check for alerts on logins? Like where do our systems keep track of people attempting to log in? Well, we know on an Ubuntu system, because we just did it, that it is down in var log auth log, right? That's where we were looking. We were in var log, like most modern Linux, but they're using auth log to send all of their syslog alerts for authentication, right? User stuff. We can look at that here in a second if we want. In fact, I don't think I even have it over here where that's configured, but I'll show you that here in a second. In the Red Hat side of things, so if I'm on a Rocky box, so like this server, this is going to be in varlog secure. And varlog secure, you'll see all the people trying to log into my server, right? These are users attempting, somebody tried to log in as the Ubuntu user. That's not a real user in my environment. There's a user Ubuntu over here. Somebody tried to come in as the admin user. That's not a real user in my environment either. And it's all over here. What even is an invalid account? It doesn't take sudo. Doesn't it take sudo user to run add user? Yeah, so Northern Chimp. So what an invalid account is, like, look, this is like, this says invalid user Ubuntu. That just means that is a, I guess you would say in a non-exclu in an it is an exclusion of all known users. So what I mean is every other user that isn't, if you were to draw like a Venn diagram and say, here's all my users right here, here's all my users, Scott, S. Champagne, whatever all my users are in my system, anything that falls outside of that gets logged there as an invalid user. That could be root number 1. That could be root number 7 because there's only a root account, right? Now the root user will not be invalid. So if we were to look in here, we looked for cat varlog secure. If we were to grab, watch this. We'll look for root, and you'll see a whole bunch of failed password for root because people try to get in my system as the root user. This is exposed out to the web. But root will always fail because it can't log in. We have a Unix, you can't use a password to get in, and you can't even log in the root user set to no from SSH, right? So you'll see failed password for root, but you won't see invalid user for root because root is a valid user. That is a very, very important distinction to make because you want to be looking for that word invalid inside of your SIEM solution. In whatever is aggregating and looking at the logs for you, you need to be looking for invalid. And when I say that, I'm telling you, you could have a user, you could have one of your admins every morning or on the night shift look through logs and stuff, but that's not super efficient, guys. What's better is to have something like this, right, where this is all of our log. Oh, well, apparently not. If I can get into my system, I thought I was logged in here. And here are failed logins for my system, right? And these can trigger alerts to me when I get failed users for, let's say, certain users, or anytime I see invalid users, I can get those to drop in if I want to. Hey, Paul, how's it going? Thanks for that Prime. I know you could use that anywhere. You chose to use it here. And 38 months, man. That's actually funny because me and Paul have probably known each other closer to like 12 years or so. So it's probably a little bit longer. But yeah, I appreciate you hanging out with us, Paul. We're just doing security stuff, and we're asking ourselves questions, and we're walking through the labs over here in Killer Coda, right? So for anybody following along, the answer to where you check for alerts on logins are on the systems. If they're Ubuntu, they're varlog authlog, and if they're RHEL, they're varlog secure. Now, where is that configured? That's actually configured in your etc rsyslog file. So if I were to cat etc rsyslog.conf on this box, we won't see it here. It's actually not here. And you say, Scott, you just lied to me. Hold on. Hold on, guys. I'm not lying to you yet. I will lie to you in the future, but not now. I'm just kidding. etc rsyslog.d, that is a extension of this configuration file. Anything in there is going to be read as well. So let's go into etc rsyslog.d. And in here, there's this cloudinit.conf and a default. Let's go look at what the defaults are. Let's just do a more on 50. And here's all of our auth and all of our priv activities go to varlog authlog. In fact, if you wanted to know everything that was going to varlog authlog, you could just grep from that directory, and this would be all the information. You'd see the commented out stuff. You'd see this shows right here that everything goes into authlog, but it looks like some things are also going into syslog, so that's good. Paul, you said build Rocky systems. Nice. Or you said Rocky 9.7. Told you in chat you can't get Rocky 10 to install on my older server. Yeah. Paul, I can see that. Like I even have on my older XCPNG environment, and it's not because it's XCPNG, it's because it's older hardware. I can't really run Rocky 10 on these. It's not going to work. But I can on my Proxmox environment. So my Proxmox environment, which is kind of like my newer server, this one can run that stuff, but I just haven't gotten around to building it out yet. It's actually funny. This thing's been sitting there running since October, and I've really only built like one thing on it. I just haven't had time. I've been working on my dissertation. I should be done with my dissertation this year. I should defend at the end of the year, so that's what I'm working on there. All right. So we did that first part, and then I did ask right here, how do we check the configuration for logging? It's in etc rsyslog.d, and in there we found this 50-default.conf, and that thing had the configuration. So there we go. And then I said, what is an invalid user? And it's an invalid user is something that doesn't exist on the system. So if we were to, on control plane here, let's do an ID for real user. We find out that real user was created on this box. It's part of the lab setup. But if we ID what suspect, I think it was like suspect 1, there's no such user. And if I were to look for real user from Etsy Pass WD, the user is defined in there with its normal 7 fields. But if I were to look for suspect 1 or whatever I did, what was it? It was, suspect 1. Those aren't real users, so they're going to show up as not real. It's video picky. Interesting. Yeah, Paul, that's a interesting thing. I wonder if you can turn something off, like if you did like a minimal install, if you could get it to at least load. That's what I tend to do. I'll do like the smallest install possible, see if I can at least get the kernel to boot, and then I'll start everything else after if I need to. Like if you're just failing on like a module load or something, like if the video's being called, if the kernel's being called and then the kernel's going to demessage and then you're like dropping to a rescue shell or something, you can almost always get that to start, but you might have to blacklist some modules, stop some things from loading, and there's a certain level of effort. Like if I'm building a new system and somebody asks me to build a certain type, and I go in and I give it maybe 10 hours of that type of work, and then I find that like no, it's going to be too much hassle for us, then I'll kind of back off and I'll call it unbuildable for our environment or whatever, because you don't want to be wrestling with that across especially different types of servers when you go to deploy those and test those. So but anyway, so now we know what an invalid user is, and then I say, how do you add the real user? So if we SSH to node 01, actually we'll do it as a lab right here. You found out from your security team that the one user that's supposed to exist is the real user. So this user is supposed to be there, but it's not there because it's still failing. So we're going to SSH over to node 01 here in a second, and we're going to create the real user, and then we're going to make sure that they can log in. Root needs to be able to log in as that user. So let's test a few things. So let's look over here. We've got the real user. Somebody made it as part of the lab. But over on node 01, there is no real user. The real user is just a name. Suspects are just a name, so there's no relation to whether they're real or not based on the shadiness of their name. I did that in the lab to mess with us, but technically, if you called your user account suspect 1 and suspect 2, that's a perfectly valid account, right? Most of the times I'm used to like SVC underscore for like service accounts, and SVC underscore Ansible or SVC whatever. Maybe you don't have the underscore, just SVC Ansible. Those are perfectly acceptable names as long as that's what your team wants to go with. All right, so anyway, so we come over here. Let's go make that user, real user, and then we'll normally we, again, and I point this out here in the lab, normally we wouldn't do this. We wouldn't make users directly on systems. We're doing it for the lab. A lot of times in the enterprise, we connect our servers up to any type of LDAP or Active Directory that the business is probably running for all kinds of other things. And then that's how we allow users into our system, right? So how did we set the real user password? Well, now we can set up we'll go over to SSH on that box and we'll set up the password for the real user. And we're going to put in the password 1234, 1234, and it will update the password successfully. That's the name that's the password we chose to use. And then we'll hit enter twice. Then we're going to exit back, and we're going to wipe the varlog auth log of node 01. Now that's not normally something we would do in a production environment. We normally don't wipe logs like that, but perfectly fine in a lab environment. Just understand that you normally don't wipe logs. That is something that's more like a, we were talking the other day about like attack.miter and how people do what's called detection evasion, and they will delete logs on servers that they're on, which is one of the reasons it's so important to have them off the servers all the time in real time. So we changed the password. How can we check that the password was set? Well, we can go back over there, ch node 01, and we could check the ch for real user, and we can see that the password was changed today, right? And we can see that there's no setting. These are all going to get you violated in a security sense, but we have them at least. that we can see if the password expires, if it's inactive, if the account ever expires. Those things almost always have to be set to some future date in like a production environment, and then they have to be audited, because what happens is there's a account rotation and job duty rotations within businesses and stuff, where we don't want when somebody, let's say somebody's on your Linux team and then they move over to like an architecture team, you don't want to leave them in permissive groups that they shouldn't have permission to anymore. That's a very bad practice. So one of the safeguards to that, or one of the things that's been kind of commonly accepted from the field as like a good way to do that, is to make sure that things expire. And if they are needed, it's considered kind of more of a, in the world of like hassling people, I would rather have one of my engineers have to hassle with getting their passwords set back up and their account set back up for a few hours than the over permissive permissions to just do whatever the hell they want in the company for the rest of the time they're with the company. That's kind of a security posture choice, but that's kind of where most companies have fallen. So stuff like this, and you say, well, why is it set like that out of the box on Ubuntu then? Well, it's the same kind of reason I tell you guys for any type of operating system. You are almost always going to have operating systems err on the side of working over security. And the reason is, you say, well, why was that? Don't they want to protect the user? Well, of course they want to protect the user, sure. But they want people to use their operating system. And if you make the things lock people out all the time, the average user will never use your system. That's just a fact. You have to make desktops like Microsoft Windows accessible, and you say, oh, that's terrible. Well, it's one of the reasons that Linux desktops, I mean, I was hearing a thing the other day, oh, all these people are exodusing off of Windows 11 over to Linux desktops, and I'm like, yeah, that's probably wonderful, but I'm going to tell you, most of them aren't going to stay once they have to deal with, the difficulty of some of this stuff. And the more it's locked down, especially if they go locking it down as they deploy it, the less those people are going to stay, because it's a lot of work to hassle with a lot of this stuff. And you say, isn't that true on Windows? No, they let you do whatever the hell they want. The only thing they force you to do is reboot every month, which is a hassle. Oh God, I hate when my systems are rebooted. But it is working out in the industry. You got to deal with what you got to deal with. All right, so let's go back to the main system, and let's look at this script that we have. There's a script here that's going to try to do some things. Did I make a? Yeah, we made a password for the real user. We cleared out that, and we're going to rerun the script to see if there's any problems with our system, right? So let's run the script. I think it says it takes about 25 seconds to run because there's a timeout for each of these. And is there an error in that? Oh yeah, because it's trying to do each of those, suspect 1, 2, 3, and then real user. That's not an error. I was just. All right, so then we go over here and we look at invalid, and we only have 3 invalids now. It's the suspect 1, suspect 2, and suspect 3. You see them right there. They're kind of broken up by the size of the screen here, but they're suspect 1, suspect 2, and suspect 3. Okay, so we see that those were invalid, but we still had a problem logging in on Node 01. Node 01 did not, real user did not log in. And the reason real user didn't log in is because we don't have a key set up for it, right? So there was still an error. It says right here, you'll see errors with the login, but at least now the real user is no longer invalid. He's not in the invalid list of users. Okay. So come down here and it said, we want the real user now to set up and be able to log in. So root's going to be able to log in as the real user. Now what we're showing here, what I'm about to show, is not extremely practical. It's not really what you're going to do. But if you've never made a key before, this may be a valuable little lesson for you, right? So we're going to create a key for root called real user underscore RSA. We are not going to overwrite our base key. If you do that, you'll break the lab. So if you just hit enter, 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 you're going to break the lab. And you deserve the lab to be broken because you didn't read ahead. But anyways, it's like we're going to create the key, we're going to push it over, and then we're going to see that we're the right user. So here's the solution. We're going to do an SSH keygen, and it's going to say, where do you want to save this key? And we are not going to use the key value right here of root.ssh ID. We're going to use this value right here. So it says save the key as this. So you can right click, paste, do whatever you want to drop it into the browser. And then we don't need a passphrase. So it's going to generate a key for us. If we were to ls-l on root.ssh now, we would see that real user RSA key. This is the private version of the key that we never share. It has 600 permissions right here. That's 600. And then the public version of the key can be shared far and wide, and that one has 644 permissions, right? 6 is read write with no execute, and then read for the group and read for everyone else. So we can share that public key wherever we want. Okay. So we go and we look at this. We can copy that key over, but when we do that, we need to know the password of 1234. And now once that's happened, we should be able to SSH over there as that user and see that we are that user. So with the ID command on that far node, node 01, our root user logged in and sees that they are the real user on the system. So we have now tested that. Like if I was being asked, hey, can you get in remotely and generate a shell inside of my account? Yes, I can do that. If real user was, I don't know, some person, some account, some service account for some process or whatever, and they say, we can't get in. And I say, okay, what are my options? I can go look at the logs and see what breaking, it's almost always a password or a key or something. But then another test is, can I get in? Can I push a key over? I could also SSH over there and sudo up to their user and see if I have the, am I inheriting an environment? Are all the things working the way that they should? We can do all of these type of tests, right? But as it were, we just kept pushed over a key and got it to work. So we connected to the server and it says, look at you learning Linux security. You looked at logs for login issues and then created a user key to verify connection. Okay, cool. Down here, we could change passwords. We could lock passwords. We could lock the user account if we needed to. We could unlock the user account if we needed to. We didn't do that. But if we wanted to do that, right, let's clear the screen, SSH to node 01. And earlier we did a chage-l and we saw these values, right? And we see that the account, last password account expires never. We see all those things, right? I should be able to do a passwd-l on real user. And it says the password's been changed. And then if I do, I should see, we see nothing there, but I should, if I grep real user from etc shadow, I should see something in here that lets us know that the real user is not active anymore. Let's make it unlocked. We'll unlock the user, right? Pull him back out of there. And you see that that lock has been pulled off. That's how they choose to do the lock right there in etc shadow. Typically, you don't show people this, but this is a lab environment, so we really don't care. The shadow file should only ever be read inside of a Linux system by processes that are interacting with PAM. Your pluggable authentication modules should go and do that stuff for you. Okay. Password complexity rules. So let's say that 1234 wasn't secure enough, because it really wasn't. Where might we set them? These PAM password quality files. Where would we set them? And typically should be under etc security, but I don't think it's there in, it may be there in Ubuntu. I'm not sure. Yeah, I don't see it here. It's definitely over here in RHEL though. So if we go to RHEL, there's our password quality if we want to set password quality for our system. And there are a lot of values you can set here. There's a lot of quality things that you can do. Do you have a minimum length? You got to uncomment these, by the way, to use them. Do you have a certain number of digits, right? So there's 4 character classes, right? There's lowercase, there's uppercase, there's digits, and there's special characters. Lowercase and uppercase are 26 and 26, right? And that makes sense. And then digits are 10. We have 10 digits in our system, right? And then special characters, there's 10 as well. So that nets you a total of 72 usable password characters, right? If you force them all. So now look, we can have dictionary checks that can go look for common dictionary words. Some of them that are kind of wild. So here's lowercase credit, uppercase credit, digit credit, min length, right? All of these. O is if you have other characters, right, or special characters. And then they've got, this one is the one that's wild, the maximum allowable consecutive characters in a password. And you can set that, so a lot of times you have to set these in like STIG requirements. And like the max repeat is 3. You can never have more than 3 lowercase in a row. So, or numbers, digits in a row. So if you set that to 3, and then somebody tried to use like a date, like, oh, I graduated school in 2000 or something, they go 2000, and then once that 4th character hits, this one would stop. The max class repeat would stop them from being able to put that password in. It's a super. These are like the biggest hassle in the world. I hate these so much. And normally, actually, government systems used to always require 14 for the minimum length. I think that's still true, but you have to turn a bunch of these other ones on. We can go through them if you guys wanted to see them in STIGs. Like if somebody was like, "Hey, pull up the STIG viewer and show me for Rel 9," I could do that right now. But that may bore some of you literally to death. But that is something that you might be called on to do in your career, guys. So, as I show you guys this stuff, I don't want to cherry coat it. Some of this stuff is terrible. Some of this stuff is not fun. Some of the stuff that you're like, oh, it's all cool security stuff. Some of it's tedium. But on the plus side, hold on, there is a plus side to this. Once you set these and once you know where they're at, then we automate it, right? Like I can fix that with Ansible just up and down this file. In fact, if there's so many edits to the file, I'll just dump my own file in there and just write over the top. Yeah, I work with STIG. Yeah, I use STIG Viewer when I do STIGs. I'll pull up the STIG Viewer real quick. This is and this does not have a nice dark mode, so I apologize, guys. But these are like common STIGs that I work right here for government stuff. And we could come over here and we could filter down to like PW quality. And here's the password quality ones, right? You can see a bunch of the values over here. It even tells you how to go fix them. Etsy security password quality, L credit is equal to -1. That's not good. So we have to set it. It tells us how to fix it, right? You have to update that to have at least one lowercase option, right? So it must have at least one. And then they tell you to go set that. And then once you do, then you can, inside of your checklist, you can do all that. I typically do this kind of stuff, and then I turn this in, like when I'm first building out supercomputers, I will turn that into the information system security officer for like a government project. They'll look through all of my STIGs and make sure that they're at the score that we say they were. But again, we're looking at this stuff like if we were just doing it for the first time, right? So where do you go set those up? You do Etsy security, PW quality. I actually don't know we'd have to go look where that is in maybe there's a separate, actually here's a good way to say it. So grep-i, let's see if they have it in one of these. No? All right. How about just credit? Nope. Yeah, I don't see it in there. There's probably some place I can go figure it, but I'm not sure exactly where it would be in Ubuntu. Said, can you generate an RSA key pair? Yeah, SSH-keygen. That'll walk you through it. Can you find where that key was generated? Yeah, it's always in your users.ssh directory by default. You can change that, though. That path, I could have changed that path anywhere I wanted. Do you know the public versus private key? Yeah, here we go. Look, this is when we originally did this, probably like over a year ago. So that was January 31st of probably a while ago. Private key is 600 permission. Public key is 644. And then I say troubleshoot the key file. If the user set the private key to open, how would you see that? So this is an interesting thing. If I cd, let's go out of here. We had jumped over when we do this, we're jumping over with our key. And I can prove that by going to root.sh, right? And then in here, ls-l to see my ID_RSA is the private key I'm going to head over there. But I'm going to change mod that to 644. I'm going to make it too permissive. And when I do that, now when I try to SSH to node 01, my system's not going to be having it. It's like, whoa, you're using a permission or you're using a file that's like way too accessible. So I'm going to go ahead and ignore it as bad permissions. Now my only way to get into Node 01 is with a password that I don't know, because I use keys for everything in the lab, right? So now I got to go back out of here. I got to change that permission set correctly back to 600. And when I do that, my SSH works again. So it's very important that you're protecting your secrets in a system. You know, you're not leaving them too open for people, right? There are other things that also have to be there. So cd2.sh ls-ld if you want in that directory. The directory must also be 700 as well. So 700 means that it's read, write, and executable by the root owner. Here's the owner, user owner of the file, and here's the group owner of the file. This means that only the root owner can read, write, and execute. Now, you might say, well, why isn't it 6 like all the other ones? Well, to traverse into a directory, the executable bit must be set, or you can't traverse down into that directory. So if you're ever wondering, like, why are directories always 755 or 750 or 700? The reason that the executable bit has to be set as well as the red is you can't traverse into a directory unless it's executable for your user or your group if you're inheriting the permission from a group. So, okay, that's a lot. I expect that to be a lot, but this is the type of thing, like if you want to do Linux administration, and this was one simple, all we saw in this one was a bunch of users trying to log into the system, and then we went and ran down kind of what was happening with those users, right? That's literally all this lab was. All right, so let's go back. I'll back out of there. Again, if anybody wants these notes over here, I wrote these before, but they're up in our Discord. I can give the Discord link if anybody needs it. There's that on the Twitch side. And there it is over on the YouTube side. Also, I always forget this. I'm going to move this up just a little bit so you guys can see better. There you go. Now you guys can see your chat. All right. Yeah, hopefully this stuff's good for you, DJ. I'm trying to... I'm trying to make a group and just a place where people can go and get into this stuff if they want, because I'm thoroughly convinced this is one of the last few places that you can still get in without a degree. Does a degree help? Sure, but not everybody's going to go get degrees. So I tell people, you can do this stuff without a degree. So yeah, I definitely hope that this stuff's useful for you guys. All right, so we troubleshot the key file. We did all that stuff. Let's go look at this next one. This next one is something else. So what's going to happen here is sudo is going to be attempted on our system. So somebody's going to attempt sudo access. I'll link that to you guys here. Sudo is a way of elevating permissions and getting permissions that are defined in the system in some way. So I'm going to make this bigger so you guys can see it, but it says your security operations team has informed you that an alert for sudo activity has happened on a server. So good, somebody was watching logs. This wasn't somebody captured this by just scrolling logs. And you want to investigate the sudo logs and see what the user or users or whatever is attempting to do. Now, I'm going to back up and save for a second here. Right here, this is actually something that I forgot that I'd written down, but there's 2 valid reasons that you might see, or this is asking you a question, what are 2 valid reasons that you might see user not in sudo errors? This happens often. When you work with developer teams and you're in dev environments and they're moving up to prod and that kind of stuff, they may be trying to do something that they think they should be able to do. Not all sudo attempts are malicious. Your dev teams may be like, oh shoot, I didn't ask the admins for this piece of software. Can I just download the software and run it? Or can I just do like a DNF? And they may try, they may think, hey, I have sudo permissions to do that command. Because, maybe they went to like shoot, anymore nowadays, it used to be all Stack Overflow, but now it's like AI. It's going to tell them to do these commands, and it's going to say put sudo in front of it, and they're going to try to do it, maybe even as their service accounts. Maybe for valid reasons within the company and the company's security position, we don't want them to do that. Okay. But maybe they do need that permission, and these are their servers often, so we probably could give it to them. But I just want you guys to think that not all sudo attempts that don't work are malicious. But they are things that shouldn't just be open to the world. Because I'm going to show you guys in this lab, we're going to set them open to the world. We're going to give all our users, it's going to be the wild, wild west. They're just going to be like doing whatever the hell they want. And that's That's problematic, guys. You let a user do whatever they want, and the user will completely fill the space and break it in every way possible. And you guys might think I'm cynical about users, but I'm 100% sure when you get out there and have users, your users are going to do shit that you're going to be like, what the hell? There's a video where like the guy pulls a sheep out of this trench, and then the sheep goes over and takes 2 jumps and lands right back in the trench. And you'll be like, there's no way like this valid like dev engineer that's super smart doing all this software engineering can possibly do that. Yes, they can. Yes, 100%. Because this isn't what they do all day. They're software engineers. They're whatever other storage engineers, all these other things, and we're just doing the Linux underneath them, right? So you'd go as far as 80% of pseudo attempts are because of vibe coding or human. Yeah, I wouldn't be surprised anymore, Sergeant Silver. I deal with a lot of researchers, and the researchers are doing valid things on the system. They're trying to run stuff. They're trying to solve their own problems before they have to call somebody and get real permissions. So let's look at this, and let's look at what indicates that there's a pseudo attempt on the system. So let's go. I'm gonna make this a little bigger so you guys can see it. And it says your security teams informed you of a pseudo alert. So it says down here, logging may take a little bit of time. So we're going to wait 60 seconds. We don't need to do that because I've already talked for more than 60 seconds. But if you were just jumping into the lab, hit that button and wait 60 seconds. And then come down here and we're going to look on this system for failed pseudo requests. And I see here that this bad user's not in sudoers. All right, well, that's a problem, but bad user's trying to do something. Again, I said this earlier, the name doesn't really indicate that the user is good or bad. Whether the user exists is really the crux of this. But in this case, we do have a pseudo issue, and we can see what they were trying to do. They were trying to just become the root user. User bin su with a dash is attempting to substitute user up to the root user. And they tried to do that with the sudo command. Then they also tried down here to read root's home directory. So this is an ls, right? Just user bin ls against the root home directory, which should be in the system 700, right? Yeah, that's 700. Nobody else should be able to read /root, which is root's home directory, right? Okay, so we see that bad user tried to do 2 different things, and honestly, they're doing it every minute because I have it in a cron job. We're going to see that here in a little bit. But where is that being seen? And the place it's being seen is varlog auth.log. So that's that same auth activity that we saw before. So security stuff, generally speaking, inside of Ubuntu is going to be in varlog auth.log. I don't know why there's another auth on there. I don't know why that exists because that's not right. And then on RHEL, it's going to be varlog secure. So if people are trying to sudo up, right? If somebody's trying to become sudo up in our system, now nobody should be able to do that in our system because if anybody's come into this jump box, this is my Bastion node. So some of you guys know that I build Bastions, and then you can hop into the further nodes in our lab environment. And you can do stuff all over in our environment. It's a different topic for another day, but the point is if anybody was in here mucking around as a user, we would be able to see their sudo attempts. No users have been able to do that because if users come in, they get jailed and they get either spit out of the system or spit down into our different lab environment. And I can show you guys that some other time if you wanted, but we can see user is not in sudoers. That's how we know that there was a bad attempt. Okay. We can also check in syslog, and syslog also tells us that there was some stuff going on. We can also look for just the bad user in here. And it looks like syslog is also catching that this thing's trying to do some command. This is likely a command. Yeah, this is my cron process running and executing that command. It's trying to do this sudo up to root. Here it's trying to read, it's trying to do an ls against root. Right, so there's these things going in syslog as well on this box. All right. So we come down a little bit and we see the line bad user not in sudo, right? That was over in this one. Yeah. User not in sudoers. There we go. All right. So this indicates that the user is trying to use sudo and get elevated permissions that they do not have. Okay. Somebody didn't set it up maybe. Again, it's not always bad. Maybe somebody forgot to ask questions. Maybe it's a dev environment and they are going to people run scripts all the time, guys. Like your devs will download a script for an installer for like Qualys or Datadog or New Relic or, I mean, all kinds of things that they may be using because the setup that they saw and they're going off of, again, AI generated or Stack Overflow or directly from the vendor, is telling them, hey, just run the script and it'll set it all up. Well, that's wonderful if you're the root user, but most people are not in their company. We're the root users, right? We're like the keeper of the Linux systems. Now, you might say, well, Scott, wouldn't the posture of your organization be better to just give everybody root down in the dev environment? Some places and some people get trusted like that. They tend to be like very senior or principal, and sometimes we relinquish that control to help them, and then they will help their teams out and kind of be like intermediaries. But generally speaking, you do not want to be giving that kind of permission out in your company. And almost universally, your company is going to have policies against that. Separation of duty policies, job rotation policies, that those extend past tech stuff. That's outside of like, it's just like, we're the admins, they're not. Nobody else that comes into the company, none of your devs, none of your software engineers sign the same thing that you do as an admin. If you're an admin or an engineer for like Linux and operating systems, you almost always sign some type of elevated privilege doc. And if you haven't had to sign one of those before, I'd be surprised if you're doing admin work for anything bigger than like a 1,000-person company, you're going to be signing something like that says, hey, I understand what the implications of my permissions are. Because I've talked to the wife about this before. If my permissions were ever compromised, or if I ever just fat fingered a command and ran it against everything, I mean, NOAA would be on the news, or AAA when I used to work for them. Like, it would be on the news that night, the type of outage they took and the amounts of probably millions of dollars that would be lost, right? So it's a very serious thing. Like, being able to, I always use the example of like a sheriff in a town. You have a lot of responsibility carrying your revolver, right? Like that kind of stuff. So, all right. I've used that example for a long time, but anyway, so we can either remove user access permissions or grant them the correct permission, which is how we're going to continue with the lab. So let's also go look at how we're setting this up. So we're going to hit cron tab-L. That's all that's happening, is root's just doing its thing every minute. So this is defined here. If you needed to know cron tab and you didn't, cat etc cron tab. This is how cron works. This might be a little easier to read if I stretch it out a little bit, right? Maybe even make it a little bigger like this. That's an easier way to read. You can also learn cron through, there's good Wikipedia articles, that kind of stuff. But I just want to show you guys that there's ways to learn what's going on, but typically you got the minutes, the hours, the day. Cron is not super precise. Like, cron is not what we would like label engineering precision. Cron wakes up between the 1st and the 5th second of every minute on your system. It wakes up like a little hibernating bear, looks around to see if there's any jobs tagged to do, and then it does them, or it goes back to sleep. And you say between the 1st and the 5th second? Yeah, if there's processor cycles available to it, it's between the 1st and the 5th second. But if you guys ever go look at a system that's like really bogged down, and then you go look at like the SAR reports, and they're not exactly every 10 minutes, now they're like every 17 or every 23 minutes, that's almost all, those are always being run through cron. So that's cron not getting the slots in its time and waiting. That happens pretty regularly on Linux boxes. Anyway, so let's it happens pretty regularly on overused Linux boxes where you're having resource problems. But anyway, so we did all this, right? And I say you can see that root is using bad user account to attempt pseudo commands that it doesn't have permission to execute. So that's what's happening. So now we're going to fix this, and there's two ways we're going to fix it in the lab. I'm kind of giving something away here. The first one is we're going to give them all the permissions. We're just going to shotgun and say you can become root. And then we're going to pull those permissions back only to the two permissions they've asked for. Now, some of you are going to go, but you gave them permissions to be root. True, but we didn't give them permissions to just become root. We gave them permissions specifically to the command to become root. You might say, well, that's tomato and tomato. And I'd say, that's 6 in one, half dozen in the other. Whatever little colloquialism you want. The point is, we can grip these back and give the users some modicum of control, but without giving them without giving them everything. Okay, sorry, I'm missing stuff. Always lie and they break software. Yeah, users always lie. That is actually funny, Sergeant Silver. Yeah, There's an old saying by I think it was Edwards Deming who said well, there's a few, I've heard this said a few different ways, but Edwards Deming was famous for saying, "In God we trust, all others bring data." That's a kind of famous one. Another one is, I've heard people say, I worked in monitoring, like with Lockheed Martin, I worked with satellites and monitoring stuff. And one of the things said, "In God we trust, all others we monitor." I thought that one was kind of funny. But that's true of systems. Like, we can't just let users run around and do whatever the hell they want. Also, did I miss anything? I missed something. I saw no pressure. Okay, yeah. So let's look at this real quick. Let's go look at this next part of the solution. So there's many ways to give sudo permissions. This is important. So let's go look at the sudoers file. And in the sudoers file, there are some lines that give, in this case, root all permissions. The root user has all permissions. And also members of the admin group. So we tag the group by putting a % in front of it. That's a good little thing to know. One nice thing about this is sudoers has examples in there. So we can give this bad user, if we do an ID, if we do an ID on bad user, we now see that they're in the group sudo, right? Because we modified and gave them the sudo group. So now the sudo group has all permissions to do any command. That gives them all permissions. So, okay, that's interesting. So now we're going to sleep 60 again on this system. And by sleeping 60, that's going to give our system time to rotate the log. Somewhere in the next 60 seconds, it's going to run that thing that we wanted to. And we're going to see if we see a different error. We're going to still see that it didn't work. They're still not going to have permissions. But are we still going to see that not in sudo error? And while we're waiting, in fact, I can do this other thing. This is one of my favorite commands to show people. Sudo-L-U for the user, bad user. And bad user has permission to run all things on this. If I were to vi etc group and undo the thing that I did, so here's my sudo line. I go right here, I say $, delete to the end, escape : WQ, and I rerun that sudo, they don't have permissions anymore. But I re-add them to the bad user group, and then I rerun that, and now they have those permissions again, because that's passing through that etc sudoers file, right? I didn't have to modify that file in any way. I tagged the user to a group, and now the user has all permissions without me ever doing anything to the user. I just put them in a group that has those permissions. That idea is what we call role-based access control. When I put you in a role of sudo, like as a group, the group is the mechanism that we give you the role. But if I put you in the sudo group, you have all permissions. If I put you in the students group, you could have student permissions and teacher permission, admin, right? Whatever you have, whatever your company has, can be defined in etc sudoers. But as some of you may think very quickly, you go, oh, I got a big company. etc sudoers is going to get real big. Yes, I have been in some companies with 5,000 line etc sudoers files. It is a nightmare. It's a nightmare to fix and modify and all these kind of things. So what we do instead, and we're going to do this in the next part, is we're going to go to etc sudoers.d, and we're going to make a file in there that will then have the permissions just for that user or that service account or whatever. And then when I deploy a service account on a system with Ansible, right, because that's a user command, I can also deploy their file into the etc sudoers.d, and all the permissions that we've agreed, me and whatever team I've worked with, and I've told you guys, I'll have 200 dev or research teams sometimes that I'm working with. I can deploy their users and their permissions at the same time with the same playbook into an environment, and then all I ever have to do is go sudo-L-U and see that their user has the permissions that I expect them to. And then I can just put it in the ticket, they're good, and go about my day. And you might say, do you really do admin tickets? Been doing this so long? Everybody gets admin tickets still. I mean, you're never good. I don't think you ever get completely away from that unless you go full architect or full manager. I have tickets sitting around right now that I could be working on. I mean, I'm off for the day, but I could be working on them if I wanted to. So anyway, so we check and we give the user some permissions, right? And let's go on with the lab. So now we've given it some time. We'll go look, and now we see that the user has a bad password attempt. He's no longer not in there, but he is having a bad password attempt. That's because we haven't set the password yet. But let's go set that password. So grep var log. We see all this, and we're still getting some errors in here, but we're not getting those errors that say not in the account anymore, or not no sudo permissions, right? So let's go down here a little bit, and let's set the password bad user to 1234, because that's what the cron job is wanting to run. And then now you're going to start seeing that work. So instead of having this error where it doesn't work, right, you're going to, that's not an error of it not working. The error of it not working is up here, right? And you're seeing the auth could not identify the password. So it's a different type of error now, right? But here in a little bit, when we recheck that, it's going to work. The user is going to have the right permission. So we can give it a few more seconds, and then we can rerun that. We'll regrep that. And actually, we could use bad user auth.log, because I don't want the other noise to show up. I just want to see the auth log. So I run that, and I see now we were seeing password failures. Here's the password change right here, right? And then now we see that the sessions are working, and we're not seeing errors anymore. But up here before the password change, we were still seeing incorrect password attempts, because it was trying the password 1234, but we hadn't set the password yet to 1234, right? That was here, right? So that's where it's set, and that's how I'm passing in the password. Not a secure way to do it, putting the password in here, but that was just for the lab. So now we're going to get rid of sudo -l -U bad user. And if we grep bad user from etc group, then we see that he's in the sudo group. Now we're going to remove that permission. He's no longer going to be in the sudo group. He's no longer going to have permissions to do anything on the system. This is now broken again as far as their permissions go. And we're going to make a file, right? And we're going to just do it like this. I'm going to hit the file to just dump it in there. And then we're going to cat etc sudoers .d bad user. And all that's in that line, it says the bad user has the permission to, with no password, do user bin ls root. So become look at the root user's home directory, and user bin su, which is beat, become the root user, right? But it's because that's what it says. 5K. Oh, Northern Chimp. I've huge amounts of file. Now, each config is probably like each actual entry config is probably about 10 to 15 lines each. So it's not that many actual users doing sudo, but it is a huge file still, and it's very unwieldy. This is very easy to go check and test. So now, what am I going to do? I'm going to run that command to see what permissions this user has, right? Because this is one of those things I always tell you guys, one test is worth 1,000 expert opinions. It's a great old engineering quote that'll always work for you. But the user, bad user, has the permissions that we gave them, specifically scoped down to what's called the rule of least privilege. I'm only giving them, it feels bad, users. How's it going, Hayes? I haven't seen you in a while, mostly because I haven't been on, but I appreciate you stopping by. Hopefully this stuff's useful for you guys. I'm going over some notes and just kind of showing administration tasks, but from like a security side of things, right? Like we're doing security stuff, and then we're asking ourselves questions like, how do we give sudo permissions? And then how do we check a permission? Guys, I'm telling you, every time I've ever shown this to like another admin or engineer, they go, oh, that's really cool. I've never seen that. This is, I don't know why this is such a rare command, but once you start using this, it'll make everything you do about user interaction easier. Because you just go see, what does the user have permissions to do? What is, where have they inherited that from in the permission set? And that's kind of important. Okay. And then I say, why do we scope in the permissions? And this is the idea that I was just talking about, rule of least privilege. That is an enforceable rule within a company, because when you start to get into like ISO 27000 security type auditing, and when you start to get into what's called SOC compliance, right? And having these SOC compliances for your security teams, one of the things you have to do is have like a list of the users and the accounts. Not all the accounts typically. If you have them grouped by roles, then you can say it's role based. But you have to give almost like an accounting for, it is truly an accounting for, why do users have these permissions in the environment? And with this kind of thing, you can very quickly go check. You can write a script that'll just check that you don't have any errors, you don't have any accounts that are showing up in your environment that are doing. I mean, there's all kinds of things that we can do, but the general accepted best practice is to only give privileges that you should. And I always have used this example, so this is not a new example. This is not related to anything going on in the news. But I always give the example of like a sheriff in town. The sheriff in town is allowed to carry a 6-shooter on his hip, right? I mean, right, he can. But does he have the permission to carry that 6-shooter out like this while he's like, hey, how's it going? Having your coffee, doing whatever, and point the 6-shooter at you? No, he didn't have that permission. That's not something he's allowed to do. So where the rule of least privilege is also this idea that we run around as our user and sudo up to do the work we need and then come back down to our users. I mean, it's the same idea that like I just don't have an off button ready to push across all my environment. Why would I have that off button sitting there? Oh, sure, I'm not going to normally hit it, but I could. And I had a paste error very early on in my career. This would have been like, well, I guess it's not super early, but this was like 13 years ago. I was pulling some information for a security team, and the way I was pulling it was like this. I was searching, so I was catting out like Etsy Pass WD. They wanted to know all the users that were over a certain number in here, right? And we can do that with awk. We can look at the third field and say if it's greater than whatever. I'm not going to do that. I'm just going to show you guys what ended up happening. We're going to awk-cap F for colon, and then I'm going to say I just want to see print the first field, right? And now you've got all of these fields right here, right? So then what I was doing was I was grabbing all of these, right? Just like this. And I was copying them and I was pasting them in a notepad next to it. That's what I was doing out of my terminal. Security team asked me to do something. I was doing it for, if anybody cares, it was like it was a dev environment for like a lower court, a lower federal court, not the Supreme Court of the US, but like a federal court underneath there. I was doing this, right, in a dev environment. I was copying stuff out and I was pulling it over. Now, this was earlier in my career. Again, nowadays I could just pull them all with Ansible and like it'd be a lot easier. But I want to show you guys, it's not in here because I was on a RHEL system. So let's go to a RHEL system and do that same command real quick. Hold on. Because some of you are going to go like, this is really stupid what you did. And I'm going to say, yeah, it is really stupid what I did. But I'll show you guys because I do think it's valuable for you to understand. Let's go look here. There's one. There's another. I don't see, oh no, there's Fisherman, right? Because Fisherman can get in. He actually runs the bot out of here. And maybe that's one too as well. Probably one of his messed up accounts, but I don't see reboot in here, but reboot used to be the name of an account. I do see halt. Shutdown won't work because shutdown needs a -H or a -R or something like that, and then a command. So shutdown wouldn't work, but halt wouldn't also work because you need a -P typically. But reboot by itself is a command, right? So what I did was I went like this, and instead of copying to my other window, I accidentally right-click and pasted in the same window. Right, because I was using PuTTY. Does anybody know what that did? It pasted each of these and tried to execute them as commands. Shutdown gave me a message, and I looked at it and I was like, And then halt, well, then it got down to reboot, and it rebooted the machine I was on. It was a non-prod, like lower district court for like one of the federal government, and I rebooted one of their dev environment machines. I didn't mean to, right? And it wasn't like it wasn't quite no harm, no foul, but it wasn't quite like getting fired for, right? Because it was like a lower environment. But that's one of those things I tell you guys, but I was running around as root. If I hadn't been root, I wouldn't have been able to do that, right? That would have failed. So, anyways, I just wanted you guys to know that like rule of least privilege is a valuable thing to a company, and it is an important thing for people to do. So, all right. Anyways, so where was I at? We were looking at all these things. These are all important kind of notes as you're thinking about sudo, like, and you're like, okay, well, where is sudo happening on the system? How can I, as a admin or a user or whatever, see that? Then this also ties over into that other idea that we want to get that stuff off the system in real time. So logging and having your logging pipeline set up in whatever way that works for you in your company, right? And then what are the valid reasons you might see that? Users might be doing, they might be running a vendor script to install some tool, and the script tries to use sudo. That's very common. Service accounts will try to install New Relic, or they'll try to configure for themselves some kind of data ingester out to a cloud service that your company's paying for, and they have a valid. Oh, another one that's big is like you're using some kind of like backup tool or something, and they want to set up the backup tool specifically for their little dev environment, not the base one, and they're just trying to do something by themselves, and they think they have the permissions for it, but they don't. And then a lot of times with that, what I'll do is down in the dev environment, I'll help them enumerate what the script is doing, and then we'll take that and I can give them those permissions in the other environments with that account. And then when I write my Ansible playbook, I make sure that I do those things, and then when they go to execute or when they hit the button, a lot of times it's my account that's actually my elevated, service Ansible account that's running in that environment. But if they needed to redeploy it or something, they had to do it as their own account, they would have those permissions, but only in the environments we wanted them to. And you might say, well, this sounds like a lot of stuff to keep track. It is a lot. In a big system, this is a lot. But these are the tools that we use to build this out and check it and all that kind of stuff. How do we give out sudo permissions? I'm a big fan of this one because I just deploy them with Ansible. I even have some examples of that. I'm trying to think of where I have examples of that, but I definitely have examples of that with like some of my Prometheus stuff. How do we check a user's permissions? This is super useful. See what sudoers files and stuff that they see. Hey, Robodom, how's it going? You were here just in time for me to take a break, Robodom. So here's what I'm gonna do. I'm gonna go to my little cozy scene here. I love this stupid scene because I know a bunch of you guys are out there freezing right now, and I'll just put like let me see. Can I go back to cozy scene again? Could I put like the break over this? Can I do? Hold on, real quick. Let's go with like a capture. I might not have a window capture set up for this. I might. Let me open up Hourglass real quick and let me see. 1 second here, guys. My Hourglass. But I want it smaller. Put it down here. And then we'll say, take a break. And stretch your legs. Because if you guys have been working with me, there's a lot of stuff going on, right? There's probably a lot of stuff that you guys were looking at new maybe for the first time or whatever. So I'm going to take a walk real quick. If you guys want to hang out, if you guys want to join the Discord, Robodom's giving you guys the Discord link. I definitely appreciate Robodom when he's around. So, Paul, you said it's in the 20s up there? Oh my gosh. All right, I'll take a walk, guys. I'll be back around. Smoke them if you got them. Yep, that's exactly right. know what I should do? I should put the let me see if I can do this real quick. Robe Dom's here. We're still on break. Let me see if I can add this. I got another source here called. Where's this at? Sand. Where's my sand at? Put my sand right here. I need to fix the filter on it. Dropping this thing down. Give me a second here, guys. This thing is it drawing right now? Let me go see. I might have to reset that too. Make sure it's refreshing as it goes. I can add this. Hold on. Then I gotta make that a little smaller. Where would I want that? I guess I would want that over there. There we go. So now there's our little thing drawn down in the corner. That's funny. All right, you guys have put up with enough. We'll finish up the break and then we'll do some more Linux. I don't know where the wife is. She's having dinner with one of her friends. I think her friend's turning like 78 or something. Oh. All right. Give it a minute. We'll go back to our normal. A little smaller up on stream, but I'll leave that up there so it can draw for a little bit. How come I'm outside? Because I think it's funny. It's like I'm looking inside. I'm like, what's going on in there? You guys all cozy? You got a little bit of coffee? Got a little bit of, got a fire going? It's like 60. What is it in Phoenix right now? It is 62. So it was 66 earlier. That's the highest it got today. So that's, I think we only got in the 40s last night. But some people, I know, Rob Dom, that you're in a pretty nice climate, but some people are having, they're down in the zeros. I think Paul said he's at 20 right now. All right. What P66? Yeah. Here, I'll transition back over here. We'll drop this down. But as we're doing this kind of stuff, like some of you guys, maybe you do Linux and you do it at home, and you're like, oh yeah, no, I've set stuff up with sudoers, and it's like, yeah, that's fine. Like, probably followed along with something, or you went and read like a setup for something, and you've probably done some sudoers. But just know that users are going to give you really weird problems. Their users are going to come at you with, I can't do this thing this way. So knowing the tools to like check their permissions and check what they're actually trying to do versus what they tell you in the ticket they're trying to do will greatly help will greatly deconflict things, right? You'll probably still get some gray hairs, but you will probably have less of them than that. So yeah, Northern Chimp. I thought that was hilarious. I think this thing's hilarious still. This little guy. I think I think that's so funny. I made that like a stupid little AI thing, and then I was like, I'm just gonna put me over here outside. All right. We'll get back to serious here. So, what did we do today? We looked at users and letting users get into our system. And then we looked at attempted pseudo permissions. So users don't have a certain set of permissions. We want to either give them, we're basically punching holes in a permission ceiling, if you want to think of it like that. A bunch of ways to think of it. But literally what you're doing is tagging users into a file, the etcsudoers file, either by group or by their ID. Group ID is better, right? That's role-based access control. That's going to fit more with permission models from a company. But sometimes others, right? All right, take a break, stretch your legs. That's all done. We've done the whole lab. You can go look at some of these other things, which are like, why did I use those full paths like I did? So when I did this here, why did I use the full path of user bin ls and user bin su? Well, because that's where they're actually found along their actual paths. So you can use which or where is, and those will typically tell you things like that. And then we can go down. We see that the permissions are scoped properly. And I say, how do these permissions compare with what was given when the bad user was just put in the pseudo group? Well, when they're in the pseudo group, they can just sudo whatever they wanted, and any command would work. Why might this type of permission be more secure? Well, we're locking down to only 2 things that they can do. Granted, one of them has just become root, so that's less secure than it probably could be, but that is a more secure way to do things because now we have an auditable trail of exactly what a user can do. But harder to maintain. It is harder to maintain, but we have automated tools that make our lives easier, and we have all kinds of stuff in the automation course and in some of my other labs where we do all the Ansible stuff to see all that. And I say, if you've used Ansible, how might Ansible help deploy permissions to etcsudoers.d? You can just drop files in there. So, hello mateys, thanks for the subscription. Hopefully this stuff's useful to you. I haven't been super serious the last couple weeks. I've been working on a bunch of other stuff. I've been heavily working on the dissertation because I'm going to defend that before the end of the year. Some of you guys that have been around, and if you're down the Discord, I'm talking about stuff. I am going to be building some use cases out, and I'm going to be doing things that I can before. I'm still waiting for my IRB approval, which is my internal review board. I can't collect data until then, but I can do all my other setups. So some of you guys that know about like how I build Bastion nodes and all these other things that we've talked about in other courses and other contexts, if anybody wants to do any of those with me, or I'm going to be rewriting. I've got a. Where's my GitHub? I think this. Yeah, here's mine. I need to rebuild this one that's called Stream Setup. Terrible name for what it is. It's perfect for what I was using it for, but it's a terrible name for what it actually is. This is my Bastion deployer, right? And it was originally built for CentOS 7 and 8 nodes. It still works for Rocky 9, but I want to rewrite it and make sure that it's got all the things that it needs inside of the Bastion deploy to work properly. Where are we at here? There's our tasks. Right. I just have it all in one big main. I could break this out to the different things, but this is like where we go and we deploy the users and we do all the different stuff that we need to for that. I need to fix that up and rewrite that because Bastions are a big part of my dissertation, specifically the security around Stride and Bastions and quantifiable look at like how much they actually improve security around those. Because everybody that knows what a Bastion is uses it, right? In the government space, especially, I build them all the time. But I don't see any research on like how they're actually, what's a quantifiable, like how much they're actually helping against some of these things, right? I mean, we take for granted that Bastions work just like we take for granted that walls work, right? But like, are they actually doing things? And then there may even be, and there's always a future study. One of the things that I'm going to define as possibly in future studies is people could go in, and this may be even something that we do after, people could be looking for patterns and stuff like that, different types of recognition of what's actually going through your Bastions and turning that into like a monitoring. We may even build the monitoring tool out for as we're doing the work and collecting things, just to be able to better visualize it. And then that tool may be become the study of future. Anyways, my point is, we're going to build all that into the playbook, right? So that's something that we'll be doing in the future. Not today though, because today we're literally just messing around today. However, messing around for me is showing you guys this. If you guys want to be serious about it, this is all serious stuff. This next one, yeah, Robodom. I try to stay busy, unfortunately. This next one's going to be updating a golden image. So if you guys have never done this, this is a thing that this looks different in different environments. We are just updating a system. Like this is just going to be a live lab node, and we're just going to go in it and we're going to update it. And the pretend part of this lab, because there's always a certain amount of pretend, because labs aren't real production environments. The pretend part of this as well, whatever we update would then be taken back into like a VMDK file or a VDI instance or whatever in AWS it would be an AMI, right, an Amazon Machine Image, and then it would be ready to be deployed in the next call of whatever our if we have some kind of Terraform or Ansible that changes the way our environment works and that kind of stuff. If we were in Werewolf, which we've done this in other labs in the automation course, in Werewolf we would be like working in a cherooted environment, and then we would be redeploying it to the node. So again, when we do stuff, sometimes I show you guys this. I don't want to draw right now, but sometimes we'll draw something. Let's say I was going to try to explain something to you, right? And I just went like this, and I said, okay, for the talk today, let's say Scott explains something, right? And the thing that we want to talk about is right here, right? So here's the thing we want to talk about. And everything else in this space is over here, right? This may be very intuitive for some of you, but this is like just a big cloud, right? Because as engineers, we often just depict a cloud as like the stuff that doesn't matter, and then we say all the stuff that doesn't matter to the discussion. And you're like, you're talking about something or you're writing something up, and somebody's like, yeah, but what about the fires of Isengard that are still burning? And you're like, the fucking fires of Isengard, they took out Saruman, right? Like his strength has been broken, right? They've completely, right? Anyways, I'm just kidding, but the point is, like, people will come up with stuff that you're like, that's not what we're talking about right now. And I don't really care right now, again, because I'm messing around here. But when I'm saying like anything that you're talking about, there's these concepts that are what we call like orthogonal. They don't matter. Yeah, they do matter in some specific use case, but they're not like that important. Yeah, Robodom, we just rewatched it. Robodom, me and the wife, we rewatched that recently. You know what I'm making the wife watch, Robodom, that you might appreciate is she's like, we were looking for stuff to watch the other day, and I was like, oh, you've never seen Sword Art Online? She's like, no. And I was like, that's like, all right, some of you guys are gonna laugh at me about it. That's one of my favorite animes. Like I like a lot of different genres of anime, but I really like the way that Sword Art Online was done. I realize it's very problematic. I realize there's a lot of things that don't make sense in it, but I always really liked it. Oh, she likes it. Well, she watches anime with me. Yeah, Robodom. Yeah, I've gotten the wife to watch a lot of anime with me over time. So let's look at this in the context of we're updating a system, and then, okay, yeah, we're not going and putting the system away. We're not going and doing all these other parts of what I was talking about. And somebody may say, well, I can't learn anything unless I do the whole thing. And I say, but you can. You can learn the one little part, which is updating the server. And then you can if you ever needed to actually update a server that was in some other, in a Werewolf configuration as an image, or it was this or this or this, the techniques are the same. Right? Does that kind of make sense to you guys? Like, we're looking like this down at one part of the process, and we're not looking at the whole thing. That's what I was trying to emphasize there. Okay. Anyway, so let's do this real quick. So your server team has a golden image that it uses to deploy new servers, right? The users push a button, goes to VRO, or it goes into some system. Maybe it's even Ansible Tower. They hit a button somewhere, and they have some type of permissions to do something, and it just pops a little server out for them at the end. So that's typically coming from some type of golden image. You're not like running that directly off of an ISO, or you're not pulling the most recent image off the internet. You have some image that you keep and maintain yourself. That's going to be a general rule of engineering, is we have to control the pipeline. We can't just feed garbage in, because you will get garbage out. And most likely you're going to get a broken pipeline. But anyways, there's a security requirement to not introduce old vulnerabilities into the environment when deploying new servers. So what that means is, we patch this weekend against all the live servers, and then now we have to go back and make the golden image that's going to deploy to virtual machines and kickstart images on physical boxes and all these types of things. We got to make it at the same level of security as the nodes that we just did. So like if we moved past an OpenSSL vulnerability, we have to then go update the golden image to not introduce that vulnerability again. And you say, well, why would you actually denote that? Why would you say that, Scott? Well, because the other option is to always deploy from that golden image forever for, the next few years. And then once it gets there, then run all the patching updates to that server right then. But here's the problem. Sometimes that process breaks. Sometimes that, I don't know, the system doesn't register. But now you've still got a system sitting there until you find it or get alerted to it that is vulnerable. You have reintroduced old vulnerabilities. That's the technical term for what you've done. And a lot of times companies will have a policy against that. Because there's a policy, it becomes part of our procedure, and it changes the way that we build things. Okay. What's the question over here? Why would I use a golden image instead of Ansible scripts to harden or patch my server? So, Iqbal, that's an interesting point. You say, what? So the question was, why would I use a golden image instead of like patching my servers? And that's kind of what I was saying is, while the server is getting ready to patch or run your Ansible or whatever, it is vulnerable while it's running. Now, you might say, well, it's only a few minutes, so that's okay. But hold on a second. There's an idea of what we call pre-baking into an image, which is what we're going to do here. We're going to pre-bake things and build them so that now when the image stands up, we also save that time. Because it used to be, somebody would ask for a server build and you'd have like a week to get it to them. And it might take your team like 6 hours to build it or something if they were building it by hand. Nowadays, we could do that way faster, but if let's say I'm standing up stuff behind a load balancer, right? I'm standing stuff up in the cloud. I don't want to be laying stuff over an AMI after, because those health checks are going to start, that kind of stuff, right? So the idea of pre-baking stuff in is pretty commonly like, where do you want to spend the time? You can bring a server up and then you can patch it right then, and maybe your security team allows that. But a lot of times you'll find that teams will just be like, well, why don't we just go update that one once, test it a few times, make sure it's good, and then that becomes our golden image for the next few weeks or whatever. So you still have personalization stuff. In fact, I have a drawing. It's not in here. I don't know where I have that drawing. But I do have a drawing that kind of shows that. Let me go back to here. This is our talk on logging, right? That's a different talk. Okay. So anyway, so we'll go here, and I say your task is to update the image to the newest software packages. This process happens quarterly in your environment. Maybe it's weekly, maybe it's monthly. Typically, this is going to be automated, but we're building it by hand to see the process. Then I actually have a different lab that does this in an automated fashion with Ansible, right? But this process happens quarterly. The server's been started, and you need to update the software. So you're in the server right now. Verify when the system was last patched. Check if the system needs to reboot. See if the system has had any patches, or are they ready to deploy. So see what the installer and whatever your package manager sees as needing to deploy. And actually, it's funny. Sometimes these labs are updated and there's nothing to download. So we're going to see today. Actually, every time I go in here, it's different. And then look to see if there's any SSL packages that need updating. So let's run through it. Let's go look in varlog apt history. And it says the last time that this was patched, last thing that happened to this system was about, was that like 6 days ago? Yeah. I think that's 6 days ago or so. And what did they do? They installed whatever these things were that were needed. So JQ, Tmux, curl, and NetTools, they got installed and added to this image. Whatever this image was deployed as. So it's very likely when we go to update this system, there's going to be a lot of updates. The last update, so they did some PHP stuff. We can actually see what's been built into this image recently if people haven't wiped this log, right? We can see that there was also some other stuff installed. People installed Podman, so probably an automated process also built all this, right? Yeah, did somebody put ifconfig back on there? Somebody probably requested that. By the way, Killer Coda has a Discord, so if you guys want to go and hop in their Discord, they just moved over there from Slack earlier this month. In fact, I just joined their Discord today, so I'm down their Discord now too. But let's go look real quick and see when the was there anything for today? And there's not, so there's nothing in there from today, which is fine. And then let's go see if there's a reboot required on our system. There's no reboot required because it doesn't see that file would be there if there was a reboot required on our system. Things that require reboot, new versions of kernels, and updated running libraries, especially with different users, right? Those are things that would require that. Okay, let's go look at if there's any packages. So if there were required packages, it would be defined here. And we can actually go check those after we do the update, if there are any updates, and it'll tell us if this system wants to reboot. It's useless in the system to actually reboot because you'll get kicked out of the lab, but again, it's one of those things that's not part of the discussion. So let's install a tool called need restart. And it says that it's already at the newest version. Okay, cool. And then let's check it. Is there anything that needs to be started? Nope, no services need to be restarted, no containers, no user sessions are running those older libraries and binaries, and no VM guests are running. Okay, so there's nothing on here that needs to update right now, or needs to restart. So let's go download any metadata. So apt update will pull all of the metadata out of our system that will, it'll tell us, it'll go get all the dependencies and everything. And it looks like 10 packages can be upgraded. So let's go look at what's upgradable in our environment. And these are the things that have a newer version in the publicly available repositories. Oh, Screen? I didn't even know Screen was still being supported. I might have to go look at that. But there's an update for Screen. Okay. And then I can say, let's go ahead and look for SSL. There's no SSL in here. And there's a little warning, but that's fine. The warning is just telling us it's not a stable CLI interface, so you might not have gotten what you wanted, but that's fine. We see that it's not there anyways, and there's no SSL that needs to be updated. There's a Python one that needs to be updated, though, so you can change that if you wanted to. And you would see just Python, right? Okay. So we come back, and now it says you've checked the current state of the system. It's time to upgrade everything. So let's upgrade our system, see what packages were installed, and then verify if our system needs to update. So we're going to go ahead and do the upgrade. And we put a time on the front of it because we want to see how long it takes. And a bunch of the things I'm talking about are kind of over here. Like, when was our system last patched? Why do we want to know if the system wants to reboot? What does an update do in Ubuntu? And then how do we tell what's upgradable? Those kind of things. Why would we want to know that in an environment, right? Are we pointing at the right packages and at the right stuff? It took 13 real seconds for the system to work through everything. And then now it says that there's some system stuff that could restart, but it's being deferred. And nothing in here really requires being restarted, right? So then we go down here and we do our needs restart -k, and it sees if the kernel was updated, right? You could also test uname -r and then ls/boot and see if there's a newer version of the kernel there, which in this case, we're on the newest version of the kernel on this box, right? See that? There's no newer kernel that was added. In an Ubuntu or in a Red Hat system, there's actually a really nice tool called Grubby. I love Grubby. Right, should just be Grubby default kernel. There's Grubby. There's our default kernel. That's the kernel that our system thinks it's going to boot to. Is that the same one that we're on? Yes. So my system is going to boot the next time it boots to that default kernel. And I actually compare those in my Ansible playbooks. I compare those to see if I need to reboot a box. And then that's part of my testing when I'm in a reboot. When I'm in a reboot window and I have rebooting set to yes in an environment, then I can check that and see if a box needs to reboot and only notify the handler if that value is set. And some of you guys have seen that before, but if you need to see that, it looks like this. Root Ansible. Where's that at? That's in reboot. That's how I check in my environment. Right? I set the fact needed to false. I do a grubby check. Then I check if Ansible kernel is in that grubby check. And if it is, then I can reboot the servers. And in this case, I was just rebooting the servers without that. But only when I've set that back to true when that's in there. Is there an easier way to do that? Probably. But that's the way that I figured out once to do it, and that's the way that I do it. Right? And this, there's also, oh, I don't have it, but reboot also here would be like in, if rebooting is yes. I don't have it in this box, but normally if you guys have ever seen my patching facts, and then if patching is set to true in there, then it'll go. And if it's in the right patching group, and I normally have that down here as a condition, but it doesn't matter right now. All right, so over here, we can check everything, and we see that we're on the highest version of the kernel, sure. And I said, you need to think about why grub.cfg has a new version, an old kernel version of the kernel in there. That's because we always install a kernel and can fall back. Now, in that case, the reason that there's, yeah, this one and then the old one is if this were to, for better, for lack of better term, this is called, you know, the kernel doesn't come up and we say the box shit the bed, then you might have to boot to the old kernel to get everything running again and then maybe repatch or roll back patches or whatever, right? So that's why we always leave an old one. You never upgrade a kernel. You always install a new one and then move to that new one, always, okay? So it says we've decided to remove all container D because we don't want that running. We don't want people launching random containers. There's a new security requirement that's driving that, not our team, right? We don't have any say in that, so we're gonna just go ahead and do that. We've also had to remove bzip because it's an old obsolete package, so we're gonna get rid of it, right? And then we can go and check to see, is container D running? Yes, right? Is bzip there? Yep, bzip's there, so we need to get rid of it. bzip2, in fact. So I'm going to say get rid of bzip2 and container D. It's going to pull it off the box. And when that's done, we'll see that container D is no longer running and bzip is no longer there. Now, some of you might say, Scott, that's pretty simple. You just did that and you did it all by hand and didn't take very long. Yeah, this is a pretty simple little lab that just walks you through some of this stuff, right? And here's all the different things that we just did. But then what you would do from here is you would bounce out of that lab and you would come to our Ansible lab. And there's an Ansible lab that we'll just blow through real quick that does the same thing. So you might say, well, do I really have to install or could I just run this? Again, it depends on the security posture of your organization and this concept of pre-baking fixes in. Pre-baking is also good because then you've tested the environment and you know that your environment's going to deploy. You're not patching stuff after it comes up, which could potentially break an environment. Let's just go look real quick. Where's this at? It's I'll link it if any of you guys want to do it. I think this one is the lab. Anybody wants it? Here you go. And here you go. That's the lab. And let's let that boot up, make it a little bigger. And it says you cleaned up the golden image over in this other lab. So it references that other lab. Now your team needs you to deploy that change to all the active systems. So you set it, maybe you did this backwards. You went and did it in the golden image and tested that your system could still boot. Now you want to apply it to, you know, the 30 servers that are up in your environment or 300 or whatever. So now you got to go patch those things and do those things. So we're going to ls in here. We're going to cat our host file. Make sure our hosts are there. Good. We're going to more our remove packages.j2. What is that thing doing? This is going to give us an update of what's going on in the system. That's just a little Jinja, which if you're doing the Ansible stuff, which we have 30 labs in Ansible, it'll walk you through what all that is, or it'll show it to y'all. And then here's our actual remove.yaml. And here's what it's going to do. So it's going to go to all the servers. It's going to remove those packages and register that it's done some actions. It's going to debug it if we want it to, but I've commented that out so it doesn't clutter your screen. Then it's going to check and verify and register that verify value that it's removed those. And then it's going to write out a report from that Jinja 2 template. real quick, we're not going to spend a lot of time in the Ansible. You guys can play with Ansible whenever you like. We're just going to run it real quick. I'll show you the removal, and then I'll show you what that playbook looks like when it actually... So we'll see the playbook run here. Go hit the nodes, remove the stuff it needs to, and then we'll see it report out what it did. And again, once you played with Jinja, you're just going to... Oh! What happened? Looks like our environment has failed because something has a lock going on. So, let's give it a second. Couldn't run that, but it did remove the app over there. So it did remove it on node 01. And we're going to actually get a message at the end here. So here's our report. Control plane did not finish, so now we got to fix it on control plane. And then the removed packages, or the packages that are not there from our original build, are these ones right there. So let's run it again, because Ansible's fun like this. Run it again and watch what happens second time. Node 01 shouldn't have to do anything anymore. It should just be cool. But control plane, if it's released that lock, should now be able to remove those apps. Unless there's another error on it. We could go manually stop whatever's holding that lock if there is something. Yeah, it's actually doing it because it would have failed already. When that's done, it's going to validate, and then it's going to give us another report, and that report will then show that those things are all deleted or gone. Yeah, Sergeant Silver, I haven't seen, like, I've seen kernels mess up. Like, I mean, I'm typically at a scale of like 1,500 nodes. So when I see, when I have a kernel problem, it'll only be on a few of the nodes, and typically because they're on different type of hardware, they have different modules or different types of things in them, and it's one of these things where, you know, when you're in big environments, and you're probably in a big environment too, but I'm just saying sometimes like one or two things somewhere will be weird. So I always tell people, like, I do what's called in automation, I try to do what's called painting with a wide brush. I don't know if anybody else says that. That's how I think of it. But it's like if I wanted to paint that wall over there, I wouldn't use a little toothbrush to paint it. I would get the biggest brush I could to hit the most space, try to get, you know, it's that Pareto's rule of 80-20. I try to even hit closer to like 90%, 95% if I can on nodes, because then I only have 50 nodes to go resolve across 1,500, and me and my team of, you know, maybe 7 or 8 engineers can go and mop those up pretty quick, right? It's like you try to mop up what you can. So let's, here real quick. This is the bigger report here. Control-Shift-V, we'll just paste it. And then it says now control plane, container D was removed, and then node 01 says those were removed. Now, we obviously have some kind of weird condition that's happened because bzip2 was not registered as being removed from control plane. So bzip's not here though. It's not there. And then we can grep bzip from var log. We do everything, right? And then just see if it's actually been removed from there. Not installed. So tried to check and it was not installed. So, okay. So it was removed. Yeah, it did remove. Probably on that first one before that lock broke. That was just a module breaking. So you said that's how I painted the old place. That's funny. All right, so look at you learning Ansible. This was not the purpose of this, but I wanted to show you guys that, like, all those things we just manually did, oftentimes you'll see me show you guys stuff manually, or I'll walk you through a system and we're hitting all of these different, you know, commands, and we're asking ourselves these questions. But then you say, okay, I'm ready to suit up and go do those individual commands as an admin. And I'm like, whoa, we don't do that here. What we actually do is, you know, run our playbooks and we make stuff nice. We mess around down in the dev environments and we can get our commands the way that we want. But then when we're ready to like go in and play and do them for real, we run through them as playbooks, right? So it minimizes our problems. But when I'm first showing this to you guys, because somebody on stream invariably has not done this stuff in Linux, and that's fine. That's the goal of this, is to get you guys into doing this stuff professionally. I can show you guys these things and you can go, oh, okay, that makes sense. But just know that you're probably not going to go individually check all your nodes for depackage. You might run a shell script against all of them. You might run an Ansible playbook, but you're probably not going to go manually check for some package that's been deleted. That would be. How's my buddy Jared do it? Jared always says that's not an optimal use of my time, and I always like that one. I thought that was funny. On the carpet on the wall, who would have known? Yeah, Hayes. I used to. When I was in high school, I used to do roofing. My uncle had a roofing business, and I would go and roofing in summer in Arizona, in Phoenix specifically, is probably just as bad as any of you can imagine, because like it'll be 110 to 120 out, but on a roof it'll be closer to like 140, and that's terrible. And then the other one is, but where I'm going with that is my uncle one summer, I remember, I want to say it was my junior year, he loaned me out to one of his buddies that owned a painting company. He's like, yeah, here, just use my nephew or whatever. So I went and I taped off for like a whole summer inside of people's houses, which was nice. But like I did the masking tape up against the wall, and then I did the half masking with like the big paper out from the wall, and then we would put the plastic down and stuff. So I've done all that stuff too, Hayes. Yeah, so that's. Oh, anyways, yeah, I've gotten paint all over the place too. Although I didn't do the painting, I just did all the tying in and all the. I did do a little bit of painting later on, but when I first started, it was all just what we called not cut-in work. What did they call it? They had a name for that. I think it was just masking. You know, I just masked everything off. That's all I would do in a room. Just make sure paint couldn't get on anything that it wasn't supposed to. And I got okay at it. I'd never say I was great at it, but I was okay at it. All right. And then there was, so this is the other lab. So we went and did that apparently when I did this. We jumped over to that lab that I just did, and we looked at all of these pieces, right? So verify our host file, verify that we can see the Jinja, and that's this one here, right? And you may, if you're not super familiar with Jinja, you might look at this and go, oh, Jinja's super easy. And I would agree with you guys. Once you get into, like, once you see this, and I tell people all the time, by all means, take this. Right, take this and use it. I know some of our guys in the Discord, and probably even more than have told me, but people tell me just a few weeks ago, someone was telling me, yeah, I've used this on a professional engagement. I'm like, good, do it, right? Like, get paid, right? Do this stuff, but do, you know, get in here. Again, once you've looked at it, you can see what the variables are, and then you look at this and go, man, that looks a lot like. It's just kind of like a little ad lib or like a mad lib, and you're like, yeah, that's pretty much all it is. And there's a little bit of looping in here with some fors, and then there's some conditional statements. Pretty easy to figure out. This one just checks a special variable called Ansible play host all. When you start a playbook, when you start a play against a run of host groups, all the nodes, all the hosts in that group show up right here in Ansible play host. This is all the people that start at the starting line. And Ansible play host is the variable at the end, well, actually at any point in time, but we just check at the end, of the play of the ones that are still running. So if I check at the end, so 100 people started this race, or 100 hosts started this Ansible playbook. At the end, there were only 79. This will show the 21 that have failed. That's all this test does. If hosts that we're checking here is not in this Ansible play hosts, meaning you start at the starting line but you didn't make it to the end, I pop your name right there. Loops over it, puts all 21 in there, boom. We can also test this, by the way. Well, we have this report where since the one failed, he didn't make it to the ending line, so he actually showed up here. But actually, when that happened, it did delete his bzip too. We saw that from the logs when we were just looking here. I've cleared the screen. But anyways, the point is, I forgot that we had jumped over to this one, but this is the package cleanup. And then I give you guys this link because this is that special variable thing I was talking about. So Ansible special variables, if you've never seen this. There's a bunch of variables that Ansible just keeps with it as it runs, and you can use any of them at any time. And you can reference them however you want in your playbook if you know how to reference them. And there's variables that are scoped to the whole playbook, which is these, and then there's variables that are scoped to the individual host, which you access like this. You go host vars to the host name, but we're looking at each host in here. And then if verify apps is defined, then we drop down here and we check to see if the verify app results has that package. So if there's a result, then we check for the package return code to be 1, meaning that it was not there and it was removed. It's just a little bit of logic that you can look at. If you needed to see that and you go, Scott, that's a lot, right? I don't verify apps, this and this and this. What you do is you go and you look at this. You VI your remove packages.yaml, and you make the thing show you. You say, Ansible Playbook, show me all the things. I need to know all the things. Right, so let's make sure it's all lined up. Debug it all. Throw it all to the screen for me. Right, so bang Ansible. And it'll rerun the playbook. And now it's... I broke something. My bad. Make sure everything's lined up, guys. YAML's terrible about that, but I mean, it is what it is. All right, but you never see that with your naked eye. But watch this. It's going to blow everything up to the screen now. It's going to debug those values for me, and it's going to say, so now if I needed to go like look at verify underscore apps dot results dot should be rc.1 shows that it was not found. All items completed, good, that's all good. But the return code 1 shows that it did not find bzip2 in the system. So there's a little bit of logic play. But now when we go look at the most recent report that we just ran, that variable was dropped there. And where's that at? More. Here it is. So that's all that logic right there. How does one get good at Ansible without even looking up things? Documentation, very proficient. I've just been using it since 2013. What I would tell you, like most people that are using Ansible, one, you know, there's this old saying, good writers borrow, great writers steal. I would find examples of what you want to do. Another thing that I would probably tell you to do is write out just the names of each of the tasks that you want. You're like, okay, I want to move this file over there. Okay, then I want to unpackage it, and then I want to run this, and I want to run that. Right? I would. That's what I would do, and then I would go look at the documentation because you guys will see me do this all the time. I'll be like, I don't remember how to use the URI module in Ansible, right? So I'll go to the URI module right here. And then I'll scroll down, and there's a bunch of like stuff that's useful here, but not what I want. What I want to do is steal examples down here. And here's examples, and I go, oh, actually what I want to do is post a form URL encoded. I want to write something into a form. So I'm going to take this, and then I'm going to go modify it for what I need. And some of you guys have seen me do that in my home lab. Is this the one? I don't know where I have it. I never know where anything is anymore. Yeah, this is the one that runs it. So let's go into roles. Where's this at? Oh, and actually it might be a little higher too, but this is one of my ones at home. And here's like my URI module to call and get information out of Loki. And Loki is a local API in my environment that I can call and I can get these logs from, right? So this is all Loki to Grafana. So I'm showing you guys something in Ansible where, and I build the variable here for the URL call, and the call is right here. So Loki host, Loki API, query range, and the query range is the value that I give. Here's our query from our query start time, and then our query start time is defined here. What is that? Prolog. What's going on here? Where is my... Oh, I'm not seeing my whole damn thing. That's what the problem is. Daily prolog YAML. Okay, so here we construct some variables as well that's local, like bespoke, if you will, to my environment. And these are things that will always be true. And I always want to look for this one message within the last 24 hours. And then that gets passed through because that variable, I always talk about Ansible having like variables in a stack that can always be called. These are then all called and put in right here. Right, so these are variables like I'm always going to have the Loki host in the same place with the same thing. Now that may be an environment variable that you pass in so you can test your different environments inside of a company or something. I have other talks and courses where we go through all the Ansible stuff, but Ansible can feed variables in 22 different ways. Most of you will never use a whole bunch of them. I only use like 3 or 4 of them. But we could hand this in from a file, and when one dev wants us to look at their environment, we could do that against their Loki instance. And another, we can allow certificate, like if we're using certificates and zero trust, because open API endpoints are often scanned if people are doing like what's that called? Like red teaming when they're doing like pen testing and stuff. They'll check to see if they can get into any open APIs that you have. So in my environment, I leave them open because we can all use them in the labs and stuff. But in a real company, you're not going to do that stuff. You're gonna be much more locked down and disciplined about it. So okay. And if it looks like I know anything, it's only because I've been doing it for a long time. It's not because I'm tell you guys this stuff all the time. If I can do it, I guarantee you guys can do it 100%. So know that that's definitely true. Okay. What's our time at? Man, we're at almost, we were doing Slurm controller the other day. I was talking about Slurm with you guys. All right, so what do we got going? We're hitting about 2 hours. I'm going to start trying to get a couple hours a night with you guys again because one, I think this stuff's valuable. I think this shows people that, we do have a pretty serious little group down there. I tell you guys all the time, if I had a superpower, it's that I've gathered other better engineers than me. So there's better engineers than me down in the Discord. I'm just a guy who's been doing this stuff for a long time. So, you guys are welcome to hang out down there. I always tell people ask questions. I always tell the senior guys, like, don't hammer the new guys, but sometimes getting hammered a little bit is useful if you're asking questions that would get you hammered out in the industry. Sometimes it's better to hear it from somebody like, make sure you check the internet first before you ask something, that kind of stuff. So, yeah, Robodom, hopefully this stuff's useful to you guys in some way. Also, I need to make that, maybe I need to make that a little bigger. Yeah, that's fine. That's fine. But we'll call it a day here. Let me go pop over here because I think this thing's funny. You guys see the little things drawing? That's my wife's little sand art up there. I can watch it with you guys here for a little bit. But we'll probably call it here. I definitely appreciate everybody coming by and hanging out. I jumped into a different, like over on the YouTube side, I jumped into a different group than I normally do. Yeah, Robodom, I haven't done my my AWS stuff in a long time, so I'm pretty far away from the gold jacket, that's for sure. Yeah, Iqbal, hopefully this stuff's useful to you. We just kind of hang out and do whatever we can. Look at our little penguin with his little camera, or with his little remote control and stuff. Hopefully you guys are staying warm out there. Don't get too don't get too cold out there. I know it's like freezing in some parts of the country, so you guys gotta stay warm out there. But yeah, I appreciate everybody coming by. We will I'll be on. Expect, especially on Sunday nights, expect me to be mostly working on academic stuff, looking up research and stuff. So I know that's boring for a lot of people, but I got to do it for my dissertation. It's like I got to take my medicine. Got to take it every day. Got to work on that stuff. But also I'll be posting in the Discord and stuff. So yeah, I appreciate everybody coming by, and I will see some of you guys later on. Take care. It's 4 outside. That's terrible. That's terrible whether it's Celsius or Fahrenheit. So.